So number 22 on your practice exam, is all about electron configurations. Yes. At a table by yourself. Guys, I hear a lot of talking that really doesn't have to do with this, okay? What?
Do you have a staple in here?
Yeah, sitting right there. Please give me your attention. William, turn around and face front, please. Okay? All right, number 22 says, what is the name of and how do you determine those elements that have electron configurations with one valence electron? Well, let's look at electron configurations. Hydrogen is 1s1. How many valence electrons does it have? Okay. Helium is 1s2, right? Well, that's not two valence electrons. Valence electrons are those electrons. Who can define from anybody? Can anybody define from what a valence electron is?
The outer.
Outermost, the ones in the outermost energy level.
Yep.
Okay. Helium's electron configuration is 1s2, so it has two electrons in the highest energy level. It doesn't answer that one. Okay, the first part of number 20. Okay, or 21. No, 22. Sorry. But it does answer the second question. Okay. The next element we come to is lithium. And lithium's electron configuration is 1s2, 2s1. Well, there's the highest energy level. That's the valence level. And there's one electron. So lithium is one of those with one valence electron in the highest energy level. Okay, and valence means highest energy level. And then there's sodium, which is 1s2, 2s2, 2p6, 3s1. Well, there's an electron in the valence level, the highest energy level. One electron there, so that answers that first part of the question, right? So basically, you just have to figure out which elements fit that. And there's a fairly easy pattern you should see after a while. If you look at the periodic table. Yeah, pretty much first row. The second part of that question says, how about two valence electrons? Well, a moment ago we said helium, didn't we? No, it's not the last row. The next element you come to that has two electrons in the valence level is beryllium. Then magnesium. Okay. Let's see. Then it says, what about six valence electrons? Six valence electrons. It'd be everything in this column right here where oxygen starts, wouldn't it?
Mm-hmm.
How about seven valence electrons?
Chlorine.
There you go. So you kind of got to know enough about the patterns of valence electron configurations to know. Okay, you should know enough about that to kind of figure that out. All right. So that's how you answer number 22. 23. You said 22 through what? Through 25. 23 says, what are the electron configurations for the noble gases?
Isn't it
Well, helium is one, yes, but the next noble gas is neon. Well, the question is, what do all these noble gas electron configurations have in common?
They all have electron energy valence levels with the maximum ability to allow able numbers of electrons.
Yeah, they have the maximum number of electrons you can put in that energy level. Sure. They have a full energy levels, valence level anyway. Okay. For helium, that's 2, and all the others is 8. Okay, that's the kind of thing you kind of got to know by realizing the pattern that exists in these electron configurations. All right, so tell me, number 24, what are the electron configurations for the group 2 elements and what do they have in common? Well, we kind of went over that, didn't we? You'd have to write all the electron configurations and tell them what they have in common. Well, what do they have in common? Group 2A. You don't know? Anybody listening? 24.
They all have 4 S sub-elements.
Group 2A? This is group 2A right here. My finger's pointing right here. What do they all have in common in their electron configurations? 2 valence electrons, sure. But you know, if you just answer that question and don't understand why, you can't expect the same exact question to be on the final exam. You got to understand why. What? Well, if you have to do that to figure it out, that's perfectly okay. But if you kind of know enough about electron configurations to come up with the answer, that's fine. That's better. Yeah. Well, look, here's the thing. Here's the thing. If you know what it is and can answer, great. But if you have to sit down and kind of write it out to figure it out, do that. You know, trying to figure out the answer as long as you have the time is a whole lot better than just wildly guessing. Even if you kind of have an idea. If you've got the time, take the time to try and figure it out. Hold on one second. I haven't finished with the one she was asking about because she also asked about 25. So 25 is what is the most characteristic property of noble gases?
They are unreactive.
Non-reactive. That's it. They have a full valence level. There's nothing there available for them to react with, although some of the larger ones can.